we will get root 2 at the denominator. Therefore, we keep this form intact. Root 2 plus minus root 34 into I divided by 2 root 3. This equation is a very simple case. Therefore, we show in the rough work the method of solving. X plus y is equal to 1, x minus y equal to 3. Adding 2x equal to 4, therefore x equal to 2. Now putting that value, now we are at the end part of the chapter complex number. Already I have solved many sums and discussed all relevant theorems. Now we started complex number to solve certain types of quadratic equations in which the quadratic expression cannot be resolved into factors, or the discriminant b square minus 4ac less than g. Now, after learning different theorems, also iota, which is root over minus 1, and learning omega, we can now solve any type of quadratic equation. Before solving few complex number related equations, I first define or state. I first state the important theorem related to algebra, that is fundamental theorem of algebra. Fundamental theorem of algebra. Though we have discussed, learned many things of algebra, but still we don't know the fundamental theorem of algebra. It has two forms of statement. First one is a polynomial equation of degree n has at the most n roots. A polynomial equation. Already you know a polynomial of n degree, that is a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an, that is equal to 0, that is nth degree polynomial equation. According to this fundamental theorem, this polynomial equation will have at most n roots. And the other version of fundamental theorem is that a polynomial equation has at least one. Both are equivalent. If you are asked to state the fundamental theorem of algebra, you can state any one of these two. Now, let us recall the quadratic equation, general form or standard form of quadratic equation. Already you have learned in the lower classes, and also we have discussed at present. That is, here of course coefficient of x square, that is a non-zero, and as per Sridharacharya formula, the roots will be given by We shall use this formula to solve any quadratic equation involving one variable. First, I take few sums where we shall use this Sridharacharya formula as well as iota. X square minus x plus 2 is equal to 0. Now first we note that the expression x square minus x plus 2 that cannot be resolved into factors. That is why we have to use here the Sridharacharya formula directly. Also we can express x square x term as a perfect square and proceed. But we shall apply here directly the Sridharacharya formula. One suggestion to students, while you are applying Sridharacharya formula, first you write down the values of the coefficients of x square, x and the constant term. That means you first compare this equation with that form. Comparing this equation with ax square plus bx plus c equal to 0, we see a is equal to 1, b equal to minus 1, c equal to 2. Therefore, using x is equal to minus b plus minus root over b square minus 4ac by 2a. Now we put the values of a, b, c. B square means 1 minus 4 into 1 into 2 . Therefore, x is equal to 1 plus minus 1 minus 8 minus 7. Therefore, we can write root 7 into I by 2. 1 plus minus root over 7 into I by 2. Now you can mention, therefore, roots of the given equation are 1 plus minus root 7 I by 2. I think you have followed. Today I have discussed first fundamental theorem of algebra. And then solved one sum here. Then I solved another sum. 3 x square minus root 2x plus this one. You can check whether the roots will be real or complex. That means we have to calculate the discriminant. First I write comparing with ax square plus bx plus c is equal to 0. A is equal to root 3, b equal to minus root 2, c equal to 3 root 3. Sometimes you need to check whether the roots will be real or complex. And already you have learned earlier that if the discriminant be less than 0, then the roots will be unreal or complex. Here discriminant delta is equal to b square minus 4ac minus root 2 whole square minus 4 into root 3 into 3 root 3. 2 minus 36 less than 0. Therefore, roots will be complex. Sometimes it is called imaginary. Better we write using Sridhar Acharya's formula. X is equal to minus b. You can put the values directly keeping in mind that formula. I write directly root 2 plus minus root over b square minus 4ac. Already we have calculated here that it will be minus 34 by 2a 2 into root 3. Now, if we use the symbol iota, it will be root 2 plus minus root 2 root 17 into I divided by 2 root 3. We can cancel root 2, but no need. In that case, we will get root 2 at the denominator. Therefore, we keep this form intact. Root 2 plus minus root 34 into I divided by 2 root 3. Hence, after getting the concept of complex number, imaginary number, etc., we can solve such quadratic equation easily, and we shall find I, that is iota in the root of the equation. Now I solve few more sums of the topic. These are other types of equations related to complex number. Mod z plus z is equal to 2 plus I. We have to solve this equation. Here, of course, z equal to x plus iy. Here, z equal to x plus iy. Therefore, mod z equal to root over x square plus y square. I call it number 1 equation. Therefore, from 1 root over x square plus y square plus x plus iy is equal to 2 plus I. Now to solve, the first step will be we write the left side in the standard form, that is of the form a plus ib, and write the right expression in that standard form. Then we shall compare real part is equal to real part and imaginary part equal to imaginary part, like this. Or x plus x square plus y square plus iy 2 plus I, equating real and imaginary parts. Then this is the real part on the left and this is the real part on the right. Therefore, x plus and imaginary part is y. Here it is 1. Thus we get first the value of y. I call it 2. Therefore, from 2 x plus root over x square plus 1 is equal to 2. Or root over x square plus 1 is equal to 2 minus x. Now we use this technique. Since there is irrational part, we keep the irrational part on the left side, apparently irrational, and the other terms on the right side. Actually, we have to remove that square root symbol by square. Therefore, squaring x square plus 1 is equal to 2 minus x whole square, or x square plus 1 is equal to x square minus 4x plus 4, or x square cancelled, 4x is equal to 4 minus 1 equal to 3. Therefore, x equal to 3 by 4. Therefore, finally, required solution x equal to 3 by 4, y equal to 1. Since it is complex number related, we have to give the answer, write the answer in the form of z. Three by 4 plus 1 into I. We can mention z equal to 3 by 4 plus I. That is the solution. Caution to you, remember, if you get z in the given equation, you are to write the answer in the form of z, that is x plus iy form. You see, after getting the values of x and y, I have given the answer in this form. Next, another sum. This is number 4. 1 minus I whole into x plus 1 plus I whole into y is equal to 1 minus 3i. One minus I whole into x plus 1 plus I whole into y is equal to 1 minus 3i. Very simple sum though. I have taken this one. Now we express this left hand side in the standard form, in the general form, or x minus ix plus y plus iy is equal to 1 minus 3i, or x plus y plus I into y minus x is equal to 1 minus 3i. Express the left hand side in the form of a plus ib, right hand side also a plus ib. Comparing real and imaginary parts. X plus y is equal to 1 and y minus x is equal to minus 3. Thus two equations, x plus y equal to 1, y minus x equal to minus 3, we have obtained. Then we have to solve these two equations. solving these equations, these equations are very simple case. Therefore, we show in the rough work the method of solving. X plus y is equal to 1, x minus y equal to 3. Adding 2x equal to 4, therefore x equal to 2. Now putting that value, 2 plus y equal to 1, therefore y equal to 1 minus 2, that equal to minus 1. When the equations will be in that simple form, ax plus by is equal to c, you can show this step on the rough space, that means on the right side of the sum concept. I have solved following that. We get x equal to 2, y equal to minus 1. Let me check. X plus y, y minus x, 1 minus 3i, equal to 1, y minus x equal to minus 3. Okay, then x equal to 2, y equal to 1. 2 plus y. Okay, I think there is no error. Next sum, 1 plus I whole into y square plus 6 plus I is equal to 2 plus I whole into x. On both sides, iota symbol is there. Therefore, we first express the left hand side, y square plus I y square plus 6 plus I is equal to 2x plus ix, or these are the real y square plus 6 plus I into y square plus 1 is equal to 2x plus ix. In the form a plus ib, this one is also in the form a plus ib, equating real and imaginary parts. Y square plus 6 is equal to 2x and y square plus 1 equal to x. We have got two equations. First one is y square plus 6 equal to 2x, right? Other one is y square plus 1 equal to x. Now I call this number 1, this one number 2. We have to solve for x and y. I use this technique, 1 minus 2. Subtract equation 2 from equation 1. Five x equal to 5. Therefore, putting this value, in 1 y square plus 6 equal to 10. 2x 25 10. From that y square is equal to 10 minus 6 equal to 4. Therefore y square equal to 4. Therefore y equal to plus minus 2. Therefore I write here required solution x equal to 5, y equal to 2 and x equal to 5, y is equal to minus 2. Therefore we get two pairs of values of x and y. Then I am going to solve another one, number 5. One plus x plus 2 minus 3i into y plus I 3 minus I is equal to I. This is the sum. Let me draw. 3 plus I at the denominator in the first fraction. In the second fraction it is 3 minus I. We multiply both numerator and denominator. In this case 3 minus I. In this case 3 plus I. Or just we add normal addition of fractions. Or 3 plus I, 3 minus I. I write first removing the brackets, x plus ix minus 2I whole into 3 minus I plus 2y minus 3 iy plus I whole into 3 plus I, that is equal to I, of 3x plus 3ix minus 6i multiplied by 3 first. 3x plus 3ix minus 6i minus ix minus I square x, that means plus x, then plus 2i square means minus 2. Just multiply it using distributive law. Now from this step I have simplified this expression, just applied distributive law of multiplication. 3 is multiplied with this expression first, 3x plus 3ix minus 6i, then this expression is multiplied by minus I, we get minus ix minus I square x means plus x minus 2i square means minus 2. Then this expression is multiplied by 3 first. We get 6y minus 9iy plus 3i. Then this expression is multiplied by I, 2iy minus 3i square y, that means plus 3y, minus I square means minus 1. And the product of 3 plus I and 3 minus I is 3 square minus I square. After putting the value of I square minus 1, that will be 10. 10 into I, 10I. Then I have taken all the real x and y terms together. 3x plus x means 4x. Then 6y plus 3y, 9y. Then minus 2, minus 1, minus 3. Then I into all I related terms. I has been taken as common factor. Then from this step 3x minus x means 2x minus 9y plus 2y minus 7y minus 6 plus 3 minus 3 whole into I, that is equal to 0 plus 10I. Since this is only imaginary, I have taken this. Then we have equated real and imaginary parts and got this equal to 0. 4x plus 9y minus 3 equal to 0, and 2x minus 7y minus 3 is equal to 10. Then in the next step, written 2x minus 7y minus 13 equal to 0. This is actually 2, not this one. Then we have solved these two equations. We are going to solve. We find coefficient of x is 4, here it is 2. Therefore, we multiply equation 2 by 2 and that result is subtracted from this one. 1 minus 2 into this is equal to 0, and this will be 4x minus 14y minus 26 is equal to 0. Signs are to be changed. (23y plus 23 equal to 0) or 23y is equal to minus 23. From that, y equal to minus 23 by 23, that is equal to minus 1. Putting this value in 1, 4x plus 9 into 1 means 9 minus 3 equal to 0, or 4x is equal to 3 minus 9 equal to minus 6. Therefore, x equal to minus 6 by 4 minus 3 by 2. Y is equal to minus 1 in 1. Sorry, this will be minus 9. Let me rectify. Four x minus 9, sorry, 9 into minus 1 minus 9. 4x equal to 12, therefore x equal to 12 by 4, that is 3. Therefore, required solution x equal to 3, y equal to minus 1. Therefore, this sum is solved.